Okay, we are now in Unit 7, Hypothesis Testing. All we're going to be doing is an introduction to this. So we're going to be stating a null and alternative hypotheses. We're going to identify the claim, and then we're going to describe type 1 and type 2 errors. This first section is kind of long, so I'm going to split it into two parts. We'll go over the first part this week, and then we'll go over the second part next week. I'll give you a short little homework assignment. Your homework for the week is actually just going to be watching this video and doing whatever homework assignment, which might be just an easy 5-question thing. I'll let you know about that by hopefully Wednesday at the latest. It'll be due by Sunday at 11:59. I know you guys, most of y'all might have younger siblings to take care of or other things, and you all might have work to do as well. So I'm not going to be as not going to have as tied as a deadline. So y'all have all week to work on this and to watch this. Just please get it done. All right. So a hypothesis test should be testing. Okay, this is a process that uses sample statistics to test a claim about a population parameter. A statistical hypothesis. Alright, so a hypothesis testing is just taking your hypothesis and going from there and testing it and doing an experiment to see if your hypothesis is true or is not true, anything that can result from that. Your statistical hypothesis is just your claim about your population. So it's the claim that you're going to work with. Okay, we have our null hypothesis, which is a no difference. The null hypothesis, we will describe and talk about it as HO. This is our null hypothesis. There's no difference. The statement of equality has one of these. So we'll have a statement of equality. It'll be a null hypothesis if and only if you see one of these following inequalities. You see an equal to, a less than or equal to, or a greater than or equal to. A null hypothesis is if in your claim you have some kind of equal in your inequality. The alternative hypothesis, that is the complement. Remember, complement is the opposite of. This is a complement to our null hypothesis. So this one will be denoted as HA. A for alternative, O for null, because the null set is actually just a 0 with a line through it. Alright, so if the null hypothesis is an equal, the opposite of equal is not equal to. The opposite of less than or equal to would be greater than, and the opposite and complement of greater than or equal to is going to be less than. So these three signs all go with the alternative hypothesis. They do not have any kind of equal sign in it, in any of your inequalities. If you have an equal sign in your inequality, it is a null hypothesis. If you do not, it is an alternative hypothesis. Okay, so we have two types of errors. You have a type 1 error. This one occurs if the null hypothesis is rejected when it's true. So basically that just means that if you work with your null hypothesis, which is say I work with the fact that my third period class has 18 people, which is true, but I conclude with the fact that that is not true, that third period has 17 people. Then my null hypothesis was true, but I rejected it. That's a type 1 error, when you reject your null hypothesis that was true. A type 2 error would be if the null hypothesis is rejected, is not rejected actually. When it's false. So if I said that, I don't know, third period has 17 people, if that was my null hypothesis, and it is not true, but I take it anyways and I say this is true, but it wasn't in the beginning, then that is a type 2 error. We'll get into a little bit more of those with a couple more examples. Your level of significance is a maximum allowable probability of making a type 1 error. Your test statistic is the statistic compared with the parameter in the null hypothesis. Your p-value. Your p-value will always assume the null is true. And is the probability of getting a sample statistic this extreme or more extreme if the null is true. Alright, our left-tailed test. Say we have our bell-shaped curve. Doesn't look very bell-shaped, but trust me, it's a bell-shaped curve. If this is our z-value, and we have the left side shaded, this is a left-tailed test, when the left side of it is shaded. You will know this because your alternative hypothesis has a less than sign. So when we state our null hypothesis and our alternative hypothesis, less than will be in the alternative hypothesis. Right. A right-tailed test would be the opposite of the left-tailed, where the right side is shaded. And that happens when your alternative hypothesis has a greater than sign in it. And your two-tailed test let's go with this again. It means you have two z-values, two critical values, and the inside isn't shaded, but the left side and the right side is shaded. This is going to occur when your alternative hypothesis has a not equal sign to it. Alright, so as a little recap, verbally, HO, remember, is the null. So it can either say the mean is greater than or equal to the other number, at least the other number, not less than. HA is your alternative. You have some. Our population parameters can either be the mean, mu, sigma, which is a standard deviation, and P, which would be in case of proportions, which that will come up a little bit today. Okay, another quick. All of these tests are determined by your alternative hypothesis. So, if it's left-tailed, if it asks you if it's left-tailed, right-tailed, or two-tailed, you have to look at your HA and tell me which sign of these it is to know. So your alternative hypothesis will tell you that. Alright. I have a little bit more details in the attached notes that will be on here. Okay, so when you are writing a hypothesis statement, the 3 steps. Your first one is that you need to translate the verbal claim into math symbols. I'm sorry, you can kind of see my cat Salem just jumping around all over the place. Okay. Then, you need to, once you have it in math symbols, you need to decide if your claim is the null hypothesis, which is HO, which you will know it is a null hypothesis if it automatically says is or is equal to. So like if it says something something proportion is 78%, then that is automatically a null hypothesis because is means equals to, so then your P would equal 0.78. Or you also need to write your alternative. So if your null is equals, then your alternative would be not equal to. Then once you have both claims written, once you've decided if the null, Salem, get down. Okay, once you've decided if you're the null or your alternative, you're going to have to write the other one. So if it was the null hypothesis and your claim was the null, then you got to write the alternative hypothesis. That's your third step. Write the other hypothesis. Alright, so I'm going to do one of these examples. Actually, I might as well just, I'm going to do about one or two of these examples with you guys. The other one can be found already on the filled out notes, which will be attached to this. Okay, so Principal Swenson claims that the proportion of seniors who graduated last year was 96%. There's no inequalities saying less than, more than, less than or equal to, greater than or equal to, or anything like that. So your proportion is, so we're going to not be working with inequalities in this one. We're going to have equality. So since we're talking about proportions, that's P. Okay. So your claim, we're working with P. So P, they're trying to tell you that the seniors who graduated was exactly 96%. So your P is equal to 0.96. Now, go ahead and write down your null, and I'm going to go ahead and write down the null hypothesis, which is HO and HA. Now, remember, this is where you need to decide, okay, this is my claim. We have translated our verbal claim. Is this going to be the null hypothesis or the alternative? If you actually look up here, it tells you that if you have equality, you're automatically the null hypothesis. So your claim would go right here. Since the alternative is the opposite if equality is not equal to. So your alternative would be not equal to 0.96. And then from here, you need to decide what kind of a tail is this. So going back to this piece of the sheet before this, you can see that we need to look at HA. Our HA is not equal to, if we have inequality, then we are a two-tailed test. Alright, doing the next one, I'm going to go ahead and write claim, null set, and alternative. Null hypothesis and alternative hypothesis. Okay, so we also have the toilet manufacturer claims the mean flush rate is less than 1.6 gallons per flush. Mean, we're going to be working with mu. Less than 1.6. Remember that is less than sign, 1.6. There's your claim. That your mean is less than 1.6. Notice that since there is no equality in this, there's no equal to on the bottom, it's not less than or equal to, it's not greater than or equal to, it's not equal to, it's just less than, that is the alternative hypothesis. So you would go ahead and write that down here. And then what's the opposite of less than? I wrote it beforehand that the opposite of less than is actually going to be greater than or equal to. So we're going to be greater than or equal to 1.6. Alright, so we stated both of our null hypothesis and our alternative hypothesis. We wrote the other one. Now let's determine, is this a two-tailed test, left-tailed, or right-tailed? Looking at your alternative hypothesis, we have a less than. It says that if you have less than in your alternative hypothesis, then you are automatically a left-tailed test. So that's all nice and done. Now then, this one I'm not going to do it with you guys right now. It is already solved on the notes that I will be uploading. With this, okay. Type 1 and type 2 errors. So your decision, if your null hypothesis is true and you do not reject your null hypothesis in your conclusion, then that is correct. You did good. That's good. But if your null hypothesis was false and you don't reject it and you say, okay, well, your null hypothesis turned out to be false, you didn't reject it and you kept it, that is a type 2 error. That would be me trying to state that my null hypothesis is there's 17 kids in third period. And then it turns out that there's not, but there's 18, but I kept that 17. I said, no, it's not. It's 17. That would be a type 2 error. A type 1 error is when your null hypothesis is true, but you reject it. So that'd be me saying that there's 18 kids in third period, but then I come to the conclusion that that's not true, that there's less than 18. That's a type 1 error. But if your null hypothesis turns out to be false, so I said that my null hypothesis was there were 17 kids in third period, and I found out, oh no, wait, I'm wrong, there's actually 18, and I rejected it instead, and I said, okay, well then, you know what, that was false, so we're going to reject it. That's correct. That's the right thing to do. Okay, I forgot I didn't do this two-sided. Alright, last page, and then do the other video another day. Alright, so let us think of type 1 errors and type 2 errors like our legal system. So you have your accusation. You are presumed innocent until proven guilty. So our null set is true until proven false. Always innocent until you're guilty. More harmful, it's because it's more harmful to convict the innocent. So a type 1 error than it is to convict the guilty type 2 error. So it is more harmful to convict the innocent. So if you convict the innocent, they're innocent, but you say no, they're guilty, then that's a type 1 error. But if you say that they're not innocent, and if they turned out to actually be, they claim that they're innocent, but they turned out to be guilty, but you kept saying, oh, you know what, I'm going to say that they're guilty, but I'm going to say that they're not guilty, that's a type 2 error. Our 3 steps. State the null and alternative hypothesis. Just like we did before, we had our claim, we said which one was HA, which one was HO. Then you need to state all possible type 1 and type 2 errors. So what would a type 1 error look like, and what would a type 2 error look like? And then you should decide which error is more serious. Would it be more serious to convict an innocent person, or is it more serious to not convict a guilty person? In this case, it'd be more serious to convict an innocent person. If somebody's innocent and you're convicting them for a crime that they did not do, that is more serious than not convicting somebody that was guilty to begin with. You actually won't be deciding which error is more serious. I just need y'all to get the hang of at least trying to figure out which what kind of error would we get. Alright, so we will let P be the proportion of vegetables contaminated by E. coli. The USDA allows for 15% of vegetables to contain E. coli. That means at most 15% of the vegetables can do it. No, anything less than that, but nothing greater than that. So a food inspector reports that a recent shipment of vegetables contained more than 15% of the vegetables contaminated by E. coli. Write your hypothesis and identify the type 1 error and type 2 error. So we ended up finding that more than 15% were contaminated. There's no equality in this, so this would be our alternative. So that's our claim. We have proportion, so we are in P. Our claim, which in this case was our alternative hypothesis, is that P is less than 0.15. That is incorrect. That more than is greater than. So our claim is that P is greater than 0.15. Okay. Fine. It's fine. Everything's fine. Okay. And down here too. So then to write your null hypothesis, it'd be the complement. So again, P 0.15, but in this case, the opposite of greater than would be less than or equal to. Okay, a type 1 error, this would look like that our vegetables have less than or equal to 15% contaminated, because that is our null set. Remember, we're going with the null set. Our null set is that our vegetables are less than or equal to 0.15%. So less than or equal to 15% of them are contaminated. This is true, so it turned out that yes, this was true, but we don't think it is. So it is true, but we're like, no, we're pretty sure more than them are contaminated. So when you think more than them are contaminated, then you don't ship. You'll stop that shipment if there's more. You can't ship it out to other people because then you risk giving them E. coli. That'd be a type 1 error. A type 2 error would be, we do have more than 15% contaminated. There should be more than in there. But, so it is true that more than 15% of them are contaminated. But we think it's less. We're like, no, that's not true. Like, we're pretty sure there's less than 15% contaminated. And so since we can ship anything that's less than 15%, we go ahead and we ship it. Okay, I can tell you as of now, looking at this, it's going to be more serious to ship for this type 2 error. To ship more than 15% contaminated than it is to have less than the right amount and not ship it. This one's more serious. You could get people hurt on that one. Okay. This third example says a study claims that the proportion of adults who are illiterate is 7%. Write the hypothesis and identify the type 1 error and type 2 error. If you see is, was, anything that's like that, that is automatically equality. Equality is a null set. So when we're doing our claim is that our proportion P is equal to 7%. Our claim in this case was a null set, so P equals 0.07. The complement of that would be that it is not equal to 0.07. Okay, in this case, our type 1 error would look like we start with saying that 7% are illiterate, and that is true. But after everything that we go through, we conclude that it's not true. So it is true that it's 7%, but we conclude that it's not. That's a type 1 error. Your null hypothesis is true, but you conclude that it's not true. Your type 2 error would be that you conclude that 7% of the population are illiterate, but it turned out that that wasn't true. So type 2 error would be the alternative hypothesis. You conclude the null hypothesis, but it was really the alternative in this case. Alright. Hopefully we can I can explain that a little bit more on the next half of this lesson. I will post that video next week. I'll have a small little assignment for you guys to do. Remember, your assignment for 2 assignments for this week is to watch this video and just to do that other assignment, which I will post through Google Classroom. They're both due by 11:59 Sunday night. Hope y'all had a great week and are doing great.